We have talked about MAC times in previous lessons. In Linux-Unix file systems, MAC times are the timestamps of the latest modification, access, and changing of an inode content of a certain file. Most specifically, M means the last time the file's data block was changed. A is the last time the file's data block was accessed. C records the last time the file's inode content was changed. Remember, in Windows, C means a file's creation time. Please be aware that the keyword last. If you modify a file several times, MAC times will only show the last time the file was written or accessed. In digital forensic analysis, we use MAC times to create a timeline of activities. Timeline analysis helps us reconstruct data to identify when activities occurred on a computer and in what sequence. For example, a rootkit installation leaves a number of files with timestamps very close to one another. However, MAC times can be easily changed by attackers. The Linux-Unix command, touch, is able to change both access and modification times. A free utility in Windows system called Times.mp4 will change all 3 timestamps in Windows file systems. MAC times are sensitive to change within the system. Running a single command, for example, copy, will change the last access time of a file. Therefore, you should always grab MAC times information before running other commands on a system. Next, let's look at utilities that create MAC timelines for us. MAC time from ThruSkit takes a data file as input and sorts the data to create a timeline. In general, creating a timeline takes 2 steps. First, you should generate a data file as an input for MAC time. The data file contains timestamps, file name, and other information. For example, both FLS and ILS can create such a data file, use -n option. In the FLS command, the option -r is recursive. -m/ instructs FLS to display output in a MAC time input format with / as the mount point of the image. In the ILS command, we use -m without / since the output from ILS does not have file name information. Once we have the data file, we can run MAC time to sort the files to create a timeline, focusing on dates and times. If you are only interested in a certain time range of timelines, MAC time will only display the files with MAC timelines in the specified time range. A timeline produced by MAC time looks like this. MAC time sorts files based on date and time. It starts by the day, in our case, Saturday, followed by months, date, year, and time in hours, minutes, and seconds. The next field is the file size, followed by a combination of 3 characters, M, A, and C, followed by permissions, UID, GID, and file name. When looking at the character after the file size, A indicates that the displayed date and the time is the last access time. M indicates that displayed date time is the last modification time. C indicates the last inode changing time. .A. means the timestamp is only for A time, and that the same file was last modified and changed at a later time. In our example, file A was last accessed at 1640.20. It was last modified at 1645.56. Its inode content was changed also at 1645.56. If the A time, M time, and the C time's last change time are all the same, you will see MAC together. In our example, file B's MAC times were last changed on Saturday, December 12, 2016 at 16:45:56. When you create a new file, you should always see the MAC combination. You should also notice from the timeline that many files have the last MAC timestamps at the time of 16:40:23. That means some activity, such as downloading or comparing, occurred during that time, since a human is not able to change that many files within 1 second. A forensic investigator will always look closely into this kind of gaps. If we create data files using ILS or FLS, deleted files are also included in the data files. Here is an example of timelines created from FLS and MAC time. Each entry from that list contains timestamps, meta time information, and also file names. Please be aware that the timelines created from ILS and the MAC time will not have the file name information. In some entries, you will see that deleted or deleted reallocate was presented after the file name. Deleted at the end indicates the file entry is a deleted file. Therefore, its content may be recoverable if the data blocks have not yet been overwritten. Deleted reallocate indicates that the file's inode has already been assigned to another file, even though its file name and inode mapping has not yet been overwritten. In our example, we know that there is a file called file 1. Its metadata has been overwritten, and we do not know where its data blocks are located and whether the data block has been overwritten. The third file is a normal file entry, just like you normally see from ls-l output.